right, here we go. So first thing we're going to do is switch and solve. Okay, cube root, cube. Okay, be careful, guys. Do not do extra simplification steps if they're not necessary. I don't need you to cube that. I need you to find y. So I'm going to add 6. So the original is cube root, x minus 6 plus 5. The inverse is x minus 5 cubed plus 6. Look at the change in the transformation. Left 6 up 5, right 5 up 6. Oh, sorry, that's a right. Right 6 up 5. Oh, the transformation switch. Yeah, because one of them describes x and one of them describes y, and then they switch. Okay? The domain of the cube root is all real numbers. The domain of the cube is also all real numbers. Because it's a cube root. It's a cube root. This one looks like this. This one looks like this. Notice that they both have positive-ish slopes. Okay, now it gets interesting. Right 2 up 4 and reflect. Okay, so we're going to do number 12. Okay. I'm going to graph it first because I'm pretty confident with my graphing. So right 2 up 4 and the reflect 2, 4, 2. 4, 5, 6, 7, 8, 9. Okay. Here's my parent. Now, I could do this graphically and I could switch. Okay, 4, 2, 3, 3, 6, 2. I could do my inverse graphically, right? It's a circle. It doesn't matter what order I go in. 2, 4, 3, 3, 2, 6. 2. Oh, I wrote my point backwards. Hold on. 2, 4. Yeah. 4, 2. There we go. Okay, 4, 2. 3, 3. Endpoint arrow. 2, 6. Endpoint arrow. Okay, that is only half of a parabola. Oh, so I should be expecting a domain restriction just by looking at the original. All I did is I switched some points and graphed it. And so let's see if I can answer these questions. Well, looking at my picture, it appears as though the domain is negative infinity to 4 hard bracket. Look at your picture. Domain and range comes from your picture. Your range looks like it starts at a y coordinate of 2 and goes up to positive infinity. Now, I could try to write the equation graphically, but I'm going to do it algebraically to see what happens. So switch. Okay. Minus 4. Okay. Divide by the negative, right? I'm not focusing on simplifying and expanding the other side. I'm just focusing on getting y equals by itself. Square both sides. Okay. Add 2. Okay. So y equals... I know that you really want to do this, so I'll do it. Because that just looks easy. It looks nicer if I do that. I did distribute my negative. You can leave it like that, guys. Why not? Is it hard to graph that? Kind of, which is why I already did the graph based on the original. Yeah.
I thought you wouldn't have to show the negative since you square each side.
You wouldn't. So, yeah, is that acceptable? Sure. Is something else also acceptable? When I square this quantity right here, I actually get positive 1, x minus 4 squared. And so that is also correct. And that's the one that I do know how to graph. They're both right. Am I going to grade you on how you simplified? No. I'm just going to grade that you didn't simplify wrong.
Yeah, like mine was
That's okay. If you foiled it, fine. If you left it here, it's fine. I just don't want you to simplify incorrectly, so don't overdo it. That's the only thing I don't want you to do. Okay. Let's go ahead and flip it over. Do a little composition. Okay. Up at the top. Whew, here we go. Oh man, you gave me a parabola? It's not even in vertex form. All right. F of g of x. All right, let's do a different color so I can see it. X squared minus 8x plus 11. Substituted in, so plus 5 plus 4. These colors aren't showing up very nicely. There we go. Okay, there's my substitution. Now I start simplifying. PEMDAS, I'm going to start inside the radical. That's a 16. Huh.
X minus 4 squared.
Yeah. Turn them into factors. Okay. Now it simplifies, right? I can't take out perfect squares unless they're actually multiplied together. All right. Okay. Now I'm going to compose the other direction. This one's a little trickier. Okay. Squared. Okay, let's see if I can't squeeze this in here. Root x plus 5 plus 4. Root x plus 5 plus 4. The trick here is you end up having to plug it in twice because there's 2 x's. And so I'm going this direction. Plug it in twice. Careful how you foil. Root x plus 5 plus 4. Root x plus 5 plus 4. First, outer, inner. Okay, outer is 4 times root x plus 5. Inner is 4 root x plus 5, so it doubles to 8. And then plus 16. That's only the first part. Now I have to actually distribute my 8. Okay, minus 8 root x plus 5 plus 32. Don't forget there's a plus 11 hanging off the end here. Right there. Okay, look for your like terms. Okay, so I have a plus 5, a plus 16.
I have a question.
I feel like I lost a minus. Oh, I see it. I see it. That's a minus. I lost my negative.
Mr.
Yes.
Why couldn't you just use the square to cancel out the why couldn't you use the square that was around x square root x 5 plus 5?
I did, but you foil. You don't lose your middle term.
Why can't you just cancel it? Why can't you just cancel it?
Because the property does not say that. The property says this. If you have a plus, this will turn into
Oh, okay.
that. Okay, look at the difference. This is the property you have to be careful with. If there's no plus, then you do just distribute that power. But because of the addition, you have the extra foiling. Okay? All right. Now I've got my like terms circled. So let's see what they add up to. So we have x plus 5 minus 16 plus 32. Oops, sorry. No, I messed up twice. Sorry, guys. No, it's a plus 16. It's a minus 32. There you go. All right, there it is. That's plus 32. There's minus 32. We get x. Whew, that was hard. Yeah. Answer is yes. Why is the answer?
Because they balance out.
Because the composition equals x. Guys, this is called an algebraic proof. Not a two-column proof from geometry, an algebraic proof where you use the definition and you proved that you got x. That means you prove that f and g are inverses by the definition. Okay, last one. These are the functions from above, so we're going to plug in -1. F of g of -1. I'm going to be funny because f and g are inverses. I don't even actually have to do anything because they're inverses. I will. I'll work out the second one. Okay? F of g of 3. So let's start with f. 3 squared minus 8 times 3 plus 11. Can someone add for me? What do we get? 20 minus 24, so we get -4. Okay. Root -4 plus 5 plus 4. Root 1 plus 3. I feel like something is not right. I get 4, but I'm supposed to get 3. What did I... Oh, no, I get 5. Okay. No, I didn't plug in the wrong thing. But I do know what happened. Look at your... This is a square root and a parabola. What's my appropriate domain? Is 3 on it. I feel like this is not the appropriate domain. 3 is not included in the inverses. That's why it didn't work. Oh, there we go. We can do it from here. What's my domain and my range? -5 to positive infinity, 4 to this. So what's my domain on the inverse?
Wait, how do you get -1? Yeah.
What do you mean?
Oh, it's the dumb trick thingy. Wait,
What?
doesn't it work for everything?
Wait, I'll give you. How does that? How?
Look at my domain and range here. Look at my domain and range on the inverse.
I still don't understand how they give you this.
Yeah, I got 9.
I got you. Hold on. I shouldn't have picked -1 is what I shouldn't have picked. Okay. So look at my 2 input numbers. Because I made a silly mistake.
Oh,
I didn't check the domain of what was allowed. If you want this to work, you need to pick numbers that are actually included on the graph. Think of it graphically. If I'm going to plug into G, I have to pick numbers that are 4 to positive infinity. That was my mistake. I'm picking numbers that weren't going to work. Right? These are only inverses on this
The
domain.
next one would be 3 as well.
It would be. Should be. I should have picked numbers that were 4 to positive infinity. Otherwise, they're not actually inverses.
But either way, if they're